It'll be live. I'm recording it live on YouTube right now. And you can, as soon as we're done, like within like a couple minutes of being done, it'll be on my web, on my channel. So if you want to go back and watch it again, you can. Okay. All right. So this says, use the following graph to determine if it's odd or even. So odd functions are symmetric over the origin, which means you flip it once over the y-axis and then once over the x-axis, which this looks like it is. So this is going to be odd. Another way you can tell, negative f of x is equal to f of negative x. So if you make, see, how can you tell on the graph? That's usually how you can tell by just looking at the formula itself. But by looking at the graph, the easiest way, like I said, is to think about the symmetry of it. Like, does this one right here, if I reflect this point over this axis, it goes here, and then over this axis, it goes there. So it worked. If I take this point and reflect it over both axes, it'll just be right here. If I take this point and reflect it over this axis, it'll be here, and then over this axis, it'll be here. You see what I'm talking about? So that's why you know it's odd. Odd functions are symmetric, sorry, over the origin. Symmetry over the origin. Even functions have symmetry over the y-axis. Got it?
Yeah.
All right. The next one says write the equation for the piecewise. So we're going to have to write 3 different pieces to the equation. Okay, this first piece right here is going to be from negative infinity. Here's how I usually write it. X is greater than negative infinity, and it is, I can't tell what kind of dot that is, equal to, and it's greater, less than or equal to -2. Okay, so that's the domain for that function. Negative infinity to -2 rather. The next piece is going to go from -2, not including it, to this point right here, which is 1. You follow what I'm doing here?
Yeah.
I'm doing the domains first. It just makes it easier for me. And the last piece goes from 1 rather, not including it, to infinity. So from 1, not including it, so don't put the equal to sign, and then infinity. So there's my domains. That's the hardest. For most people well, I don't know if that's the hardest part, but that's one of the hardest parts. So I'm going to put a comma in there. I'm kind of writing backward. And now let's go back and let's find out what these functions are. Well, this function right here is it looks like just a parabola, right? An upside down parabola that shifted left 3 and up 2. Let's see if that's true. Let's test it out. Parabolas, normally when you go over, when you start at the vertex, when you go over 1 sideways, you go down or up 1. 1 squared is 1. When you go over 2 sideways, you're going to go down 4 or up 4, because 2 squared is 4. So this is a standard parabola. There's no stretch or shrink, and it's shifted and it's flipped upside down. So flipping upside down, you make it negative on the outside, right? And then shifting it left, you add 3 to the inside, and up you add to the outside, you add 2 to the outside. So I'm just going to go for it, and I'm going to call it negative x plus 3 squared plus 2. See how I came up with that? That flipped it, that moved it left 3, that moved it up 2. Got it?
Yeah.
And let's just check for good measure. Let's check to make sure. Is my origin point -3, comma +2? How about another one? If I plug in 1, what do I get when I plug in 1? What's 1 plus 3? Let's not plug in 1 because that's going to be way down here. It's going to be a big number. Let's plug in -4. What should I get when I plug in -4? I should get that point right there, which is at +1, right? So when I plug in -4, -4 plus 3, what's -4 plus 3?
-1.
And what's -1 squared?
1.
And what's -1 plus 2? 1, which is what I got. See how I checked it just to make sure? Good. You can keep yourself unmuted, Teresa, because it's just you in here. That way we can just have a conversation. That'll be easier that way. I want to make sure I'm not losing you and I can't see you. So just give me some yeses and nos. Be a good listener. Sound good?
Okay.
All right. So what's this next one look like? What kind of graph does this look like?
That one's, oh wait, shoot. Oh, I know this. It's not square root. It's not quadratic. It's
what are V's? What are V's? What kind of graphs are V's?
That's exactly what I'm trying to think of right now.
It's their absolute value.
Absolute value, because of the value is the V. That's how I remember it.
Oh, good. Okay. So that's an absolute value graph and it just shifted how much?
2 down.
Good. And is there a stretch or shrink? Or do you usually, when I go over 1, I go up 1?
Yeah, usually you go over 1, up 1.
Good. So there's no stretch or shrink. So it's literally just the absolute value of X minus 2. That's all we did. Okay. And this last line, and you could plug points in to check if you wanted to. You can plug in 1. And when I plug in 1, I'll get 1 minus 2, which is -1. Hey, look at that. 1, -1. That worked. You could plug in -1. And when you plug in -1, you'll get 1 minus 2, which is -1. Hey, that worked too. So I'm pretty confident I did that right. The last one is just a line. And how do I tell what an equation of a line is? What's the best way to tell the equation of a line?
You just do like the up 1 over 1, and that's it. Or like
I like
up
that.
2 over 1.
I like it. It's going up 2 over 1. So if I went down 2 over 1, that would have been my next point. Even though it's not really a point on the graph, that still helps me find the equation, because this is the what? What's that called again?
The vertex. Wait, circle that again.
Called the y-intercept. Right? If I went down 2 over 1, I would get right there. So my y-intercept is -1. Remember mx plus b? And my slope, what was m? Rise over run. What's my slope?
Yeah. 2 over 1.
2x, very good. So which is 2x, right? So 2x minus 1, that's my equation. 2x minus 1 is the equation of that line, but it only is valid on that domain right there. So there's my piecewise function. Lots of stuff on that problem. There's lots of stuff to do. Let's see if we have another one. All right, let's do this piecewise function. They're telling us to evaluate it. They want us to graph it and then evaluate it. So let's do this, no problem. We're gonna graph this one first. I'll do this in red so you can see. And it's for whenever x is less than 1. Oh, by the way, see how they're writing it? X is less than 1. I could have written it like that.
Oh wait, this one's really easy. Can you just do one of these, and then can I focus on the ones after that one instead?
Yeah, but I'm gonna go back and fix. I'm gonna go back and fix this a little bit. It's not wrong what I wrote, but you don't need to write it. You can just write x is less than or equal to -2.
Okay.
And then you can write x is greater than 1 for this other one. Some books write it that way. Some books write it the other way. But yeah, that's all. That's all you have to do. Same difference, right?
Yeah, these are easy. I know how to do these. This one at least.
Okay. You don't want me to do it real quick? Just knock it off in like 60 seconds?
Okay, yeah, you can do it real quick.
All right, so there's 2, and there's up 2 over 1. So there's my next point. So there's my next point. But notice it's only valid for x is less than -1. So I'm going to keep finding those points, and I'm going to go, oh, that's where it starts. So I'm going to erase those other ones, and I'm going to start it here where x is -1, right? Which happens to be at 0. And I'm going to go to the left, and what kind of dot should it be?
Open.
An open dot. What was it? Slope was 2. So down 2 to the left 1, down 2 to the left 1. So there's my line. There's that one. Now, if I do this other one, I'll do this in blue. That's the V, like we talked about, and it's shifted down 2. So normally it would be here, and it would go up this way, and it would go up this way. But where does it define for? It's defined between -1, right? You follow what I'm saying? So it's defined,
Yeah.
starting here, which is going to be at -1, -1. Because if you plug that in, you'll see it's -1, -1. And I'm going to fill in the dot because of the equal to sign there. Okay, and then it goes up to the right. And where does it stop to the right? At what point?
2.
2. So if I plug in 2 here, I get 0. It's going to go to 2, 0, right? And it's filled in, right? Is it filled in or not filled in, the circle?
It's filled in because there's a line under.
And then the last point, the last part I'll do in red. The last part is a parabola, but it's shifted where? Good, right 2. It's shifted right 2 because it's on the inside.
Yep.
So the parabola normally is here, but it's shifted right 2. So it's starting here. Here's my center, and it's starting there, and it's going only to the right. So I'm going to go over 1. So here's my point. Now I could make it an open circle, but do you see how it's already a closed circle there?
Yeah.
So I actually can just start graphing it from here, and I know it's going to go here, and it's going to go here, because it goes over 1, up 1, over 2, up 4, because it's a quadratic. So my graph looks like this. And there's my graph. Good?
Yep.
All right, next one. Determine algebraically whether they're even, odd, or neither. Okay. So do you remember what I told you earlier on page 1? How do we know if it's even, odd, or neither?
If it's odd, then it's the same on the Y, and if it's even, it's the same on the X. I switched it around, didn't I?
Well, you kind of said it. You didn't really say it right. Here's what it is. An even function, f of x equals f of negative x. For an odd function, f of negative x equals negative f of x. So we actually have to plug in a negative. We have to find out what f of negative x equals. So let's plug in negative x. What happens when I plug in negative x here? What do I get? I get negative x squared minus 3. And did that change the function at all?
Yeah.
Well, what will happen when I square this? It's not going to change it, right?
No, it doesn't. Yeah.
So this equals f of x. So what kind of function is it? If f of negative x equals f of x, what kind of function is it?
It's odd.
Nope.
Wait, no, it's even.
It's even.
Yeah, sorry.
That's okay. So that's even, right? Let's do this next one. If I plug in g, if I find g of negative x, what's 3 times negative x cubed? What does negative x cubed turn into?
Isn't it negative? Wait, wouldn't it negative 3 of x cubed then?
That's right. Which is the same as what? Negative
3x.
f of x. Do you see how that's the same as negative f of x? Because here's your f of
Okay.
x.
Yeah.
So g of negative x was the same as, whoops, I didn't mean f, I meant g.
I get it though. Yeah.
You understand?
Yeah.
So this is what? This one
Odd.
is good. And this one, you think maybe it'll be neither, but guess what? It's odd. Now, I'm going to tell you the shortcut. You want to know how I know it's going to be odd?
Ow.
Because all of the degrees of all of the exponents are only odd, and there's no constant.
Oh, okay.
Because what happens now, look at what happens when that's the case. What happens when you plug in a negative x? When you have an odd exponent, what happens to the negative when you have an odd exponent?
It just becomes positive.
Nope.
Like, no, it doesn't.
It becomes negative. It changes the sign, right?
Oh, okay. And then it becomes negative.
So then this would be,
X.
You're right. This one became positive because it flipped the sign, but this one became negative. So what did I do to the two signs up here? What happened? They flipped. All the signs flipped. So this is equal to negative. Whoops, I should have had negative in there. This is equal to negative h of x, and therefore it's an odd function. Now let me point out something to you. That's also true for the even functions. As long as all the exponents are even, it's going to be an even function, and it doesn't even matter if there's a constant term in that case. So for an even function, you can have a constant term and it can still be even. For an odd function, if I added a constant here, let's say I added a +5 there, that would be neither, because that +5 just ruined my oddness of my function. Because I would have had a +5 here and that sign didn't change. See how the sign wouldn't have changed here because there's no x with it. Gotcha. To change that sign. So that's the shortcut. The shortcut is when it's a polynomial function like this, if all of the exponents are even, and it doesn't matter if there's a constant term or not, then it's even. For odd, if all of them are odd and there is no constant function or constant term, then it is odd.
Gotcha.
Okay.
Yep.
Page 5.
Yep.
Are we doing the one on the bottom here? Figure out if they're inverses?
Yeah.
Okay. So the way you can tell if two things are inverses, if you plug in g of x, if you plug them into each other and you get x as an answer for both cases, then they're inverses.
Wait, that confused me a little bit.
I'll show you. The way to tell if two functions are inverses algebraically is plug them into each other. That's called functional composition. And if you get x as an answer for both of them, then they're inverses of each other. So we're going to check it out. Ready? We're going to do f in red and we're going to do g in blue. Okay. So let's first do f of g of x. F of g of x. What am I doing? I'm plugging g of x in everywhere for my f function everywhere I see x. So instead of writing 2x for f of x, right?
You're going to write x over 2 instead.
I'm writing 2 and then I'm plugging in g of x. And what does that equal? Cancel, cancel. Hey, that equaled x, which is good because that's what I wanted it to equal.
Yeah.
But am I done?
No.
Nope. I have to do g of
f of x.
F of x. And how do I do that? I plug in f of x everywhere for g. So I plug in 2x.
They cancel and it's x.
Look at that. They cancel out and I get x. So are they inverses?
Yes.
Yes, they are.
That's so easy.
Well, it's easy for that one, but it's not always easy.
Yeah, that's
so
true.
You might want to find some more harder examples to do, or maybe we will if we have some time at the end. Okay. Let me do this now though. So what are we doing, the bottom 12 and 13?
Yeah, just those two. Okay. And I think that's it.
Okay, we can go back and do another one then. Find the domain. So the domain for this, it's anything where this can't equal 0. right? You can't divide by 0. So literally I write the equation out. I write x plus 2 cannot equal 0, which means x cannot equal -2. So the domain is all real numbers except -2. Or if you're writing it in interval notation,
okay.
-infinity to -2 union -2 to infinity.
Gotcha.
Same thing for this one over here. X squared plus 2x minus 15 cannot equal 0. Well, how many potential answers are there going to be for this one?
3. Right?
2. Let's factor it. X 15 is 5 and 3, right? 5 times 3. So a +5 and a -3, because 5x minus 3x is 2x.
Yeah.
5 times -3 is -15, right? That's how you factor. So basically those can't equal 0.
And then you put x plus 5 equals 0 and x minus 3 equals 0. And then, okay, I remember this.
So x can't equal -5 and x can't equal
3.
+3.
Yeah.
And so you can say all real numbers except -5 and 3, or you could say -infinity to -5 union -5 to 3 union 3 to infinity. Okay. You want to go back and do another one of these now?
I have a question for that last one.
Yeah. Yep.
Why is -5 in the y value, but then 3 is in the x value? Like, do you see that?
No, these aren't
Like
points here. This is interval notation.
Oh, okay.
These aren't points.
Because
these are all x. These are all x values.
Okay,
right?
I get it.
Yeah, that's not coordinate pair. That's just writing this -5, 3, and it's everything except those.
Gotcha.
That's all just x values. Interval notation. Good? Make sense?
Yeah.
All right, so let me ask this. Are these functions inverses of each other? F of x equal, well, you didn't really ask about how do you find an inverse? If I give you a function, do you know how to find the inverse? Do you have to do that?
Kind of.
If f of x equals 3x plus 2 over 7, what's the inverse? Do you know how to do that?
No.
So you interchange x and y. You flip the x and the y around. So instead of that being y, that's x. Instead of that being x, it's y. And now you solve it for y. So multiply both sides by 7. Subtract 2 from both sides. Divide by 3. There's your inverse. 7x minus 2 over 3. Did I do that too fast?
Yeah.
Okay, watch it again later. Now the reason I did that is because I wanted to show you how a more difficult problem would work out. If I wanted you to prove that those were inverses, how would I check if they were inverses? Remember, we just did this before. I'm doing f of f inverse of x. I'll make f inverse blue. F of f inverse of x. So I'm going to write out my f function, 3 times x plus 2 over 7. But notice I didn't write, you see how I didn't write the x? Because I'm going to write what in there instead?
7x minus 2 over 3.
Now how does this simplify? What happens to the 3 and the 3?
Cancel it out. The 3 cancels out.
The 3's cancel, the 2's cancel, and the 7's cancel. Guess what I got?
So they are inverse.
They are. Well, I don't know yet. Let's make sure. F inverse of f of x. Now I'm going to plug f of x in. right? And I have to get that same thing, right?
Yeah.
So F inverse is 7 times x minus 2 over 3. And instead of plugging x in there, I'm plugging in f of x, which is 3x plus 2 over 7. What happened to the 7s?
Cancel. 2's
What happened to the
cancel.
2s? What happened to the 3s? I get x done.
So it's
Okay. So going back, how did I do that? How do you find an inverse? This is just proving it's an inverse. But how do you find an inverse given a function? You interchange the x's and the y's. See what I did there? I interchanged them, and then you solve for the new y. So I added or multiplied by 7 first. I subtracted 2 next, and I divided by 3 next. And on my website, you can see a bunch more examples like that, okay?
Yeah, I'll probably go back and watch that one, but I got everything else.
Awesome.
Yeah, that's pretty much it. You answered all my questions.